Cloudflare had one of the worst outages yesterday, which caused a major chunk of internet to stop working, from small websites like Fermion all the way to bigger websites like ChatGPT and Claude as well. And this shows like how important Cloudflare is from an infrastructure and an internet point of view, but it also shows like how very small things can cause huge disasters like these. So let's take a look at in this video what this outage was and the detailed breakdown report that Cloudflare has released, surprisingly in less than 1 day's time. So that is really cool. And they have released this blog post, which you will find the link in the description as well. But I want to walk you through and share my point of view on how these things unfolded. So yesterday around this time, Cloudflare's network began experiencing significant failures to deliver core network traffic. This showed up internet users trying to access our customer site as an error page. So if you see this diagram very carefully, which is something which I tweeted about as well, you will see that in very rare cases, I've generally not seen this diagram, but you would see that the error is at a Cloudflare layer. It says that the host is working. I don't really know if it is actually true or not, if they actually test if the host is working or not, but they have figured it out that Cloudflare's internal system is at error. They clarified upfront that this is not a cyber attack or a DDoS or any sort of this thing, because there were some rumors going on. This was like a massive DDoS or it was like some sort of cyber attack against Cloudflare, which they clearly said that this is not this. It was in fact a change to one of their database systems, which caused the database to output multiple entries into a feature file used by their bot management system. That feature file in turn doubled in size. The larger than expected feature file was then propagated to all machines that make up their network. So this is basically the TLDR, in which they explain that there is a component called as bot management in Cloudflare's infrastructure, which uses some sort of feature file which went rogue, right? So there was some problem with this feature file, and because this is something which is propagated to all machines in Cloudflare's network, what happened was that every single machine that Cloudflare operates on the planet got access to this file. It tried to load it and everything went down. This is why this was not an isolated issue, even though Cloudflare has a lot of point of presence across the planet, but still you would see that this outage was a global outage. It was not specific to like a region like US or Europe or Asia Pacific, but it was generally like the whole system went down. So the outage, you can see clearly they have shared an interesting graph which shows you that over here you would see that this is like a 500 response graph, right? And you see that it's very minimal, depending on how you consider minimal. It's probably like a few thousand requests per second still, but you suddenly see that it spikes up over to 20 to 30 million requests every single second, right? So this peak, for example, is 29 million requests a second, which is effectively the scale of Cloudflare, I hope, right? I am assuming that this is the scale at which Cloudflare operates on a day-to-day basis, where internet traffic volume is usual. There is no Black Friday, there is no Cyber Monday sale going on. Obviously, the spike would be higher in those cases. But you see that at any given point, Cloudflare is serving roughly about 28 to 30 million requests per second, which is closer to 2.5 trillion requests a day. Right? So a massive amount of traffic flows through Cloudflare as a centralized service, which somehow got disrupted because of a bot management file change, which disrupted the whole internet. So you see that Cloudflare says that this is a graph of 500 error status codes received by Cloudflare network. Normally this is very low, and it was right up until the start of the outage, right? So this is where probably around 11:30 or 11:29 the update went, and first set of servers started to receive or started to pull the bot management file, right? And then it kept on going up and down for some reason. And I remember like yesterday also it was happening that sometimes the websites will start loading, but then they will just stop working at all, which is what they mentioned, that in the system, sometimes the system would recover for a period and then, it'll just go down again. This was very unusual behavior for an internal error. Now, the explanation was that the file was being generated every 5 minutes by a query running on a ClickHouse database cluster, which was being gradually updated to improve permissions management. Bad data was only generated if the query ran on a part of the cluster which had been updated. As a result, every 5 minutes, there was a chance of either a good or a bad set of configuration files being generated and rapidly propagated across network. So we'll get to the full picture, but so far what they are saying that if this is your computer and if you're trying to access a website which is hosted on Cloudflare network, so if you look inside this Cloudflare network, you will see that at some point, some step is bot management. which is probably part of their web application firewall structure. And then there are a bunch of more steps that happen, across the way. And then finally, they get to the origin or serving response, whatever. This could be R2 workers, your main origin, and so on. So what they are saying is that over here, what's happening is that there is a file somewhere, that is what we know for now at least, that there is this file somewhere in ClickHouse database. Using this database, there is a file which is getting generated, feature file, and this file is getting propagated to the whole network of Cloudflare, right? So wherever Cloudflare is in the world, all the data centers, I'm assuming all the point of presence which are responsible for serving traffic, they are getting this feature file updated somehow, like once every 5 minutes. So they're saying that initially the spiky data is because this feature file was toggling between bad and good, right? So there was some data somewhere in the ClickHouse database itself, which is supposed to generate this file, which is sometimes getting bad data and sometimes it's getting okay data. And if it's getting okay data and it's getting pulled by some of these points of presence, you will see these dips where 500 errors drop and then they will rise again. And then there was a time where it basically dropped to 0 again, but it rose again, dropped, and so on. It kept on happening, right? So obviously this is confusing for the hands-on team or somebody who's on call, because if this has not happened before, it's very hard to debug just from this information that what is going on. Initially, that is what they say. This led us to believe that this might be caused by an attack. Eventually, every ClickHouse node was generating bad configuration file and the fluctuation stabilized in the failing state. So on this point onwards, like after this specific time, you can see that there is no dip basically. So this was the time when all the ClickHouse clusters across whoever is generating this feature file is just generating a bad file, and this is getting propagated across the whole network. All right, so let's see how actually this went down, because Cloudflare has shared a lot more details into how this file is generated, what this file is actually, and what actually caused this to happen, right? So this is all very interesting stuff. So they say that every request to Cloudflare takes a very well-defined path through the network. It could be from a browser loading a web page, a mobile app calling an API, or automated traffic from another service. These requests first terminate at our HTTP and TLS layer, then flow into our core proxy system, which we call as frontline. And finally through Pingora, which performs cache lookups or fetches data from the origin if needed. So Pingora is basically Nginx of Cloudflare, right? So it is what performs reverse proxies and cache lookups and fetches data from origin if needed, right? But before even you reach Pingora, you have a bunch of these steps which are performed in the Cloudflare network. So they're saying as request transits, the core proxy, we run the various security and performance products available in our network. The proxy applies each customer's unique configuration and settings, enforcing WAF rules, DDoS protection to routing traffic to developer platform and R2. It accomplishes this through a set of domain-specific modules that apply the configuration and policy rules to traffic transisting our proxy. All right, interesting. So see, if we go back in this diagram a bit, you will see that from Cloudflare, you can see that I mentioned that bot management WAF is one of the parts, but you see that Cloudflare has revised the diagram a little bit, and what they are effectively saying is that even before this, what we do is something of a sorts like TLS termination, right? That is basically decrypting the SSL traffic. Then they do a bunch of checks, which is like saying WAF checks. No idea what happened to font here, but anyway, WAF checks or rate limiting. And then one of the checks that they also have is bot management, which is again part of the WAF itself, or maybe like rerouting it to some other network part like workers and all. So they might also reroute network requests to workers, R2, all of those things. And if none of that is applicable, they would probably, this happens after this, I'm assuming, they would probably just route it to the origin server. So you see inside Cloudflare, I'm showing you our Fermion dashboard, but inside Cloudflare, you see that there are things like these bot protection and bot management, right? So not exactly bot management, but you can see that this is like block AI bots and super bot fight mode and so on. So these things, I'm assuming, are part of this infrastructure piece, which is over here, right? And what they're saying is that Cloudflare's bot management includes, among other systems, a machine learning model that they use to generate bot scores for every request traversing their network. Our customers use bot score to control which bots are allowed to access their sites or not. So the model takes input as a feature file. A feature in this context is an individual trait used by a machine learning model to make prediction about whether the request was automated or not. So effectively what they're trying to do, as I understand reading this bit a little bit, is that this file that you see over here, so what they're doing, as far as I understood, is that they're storing all these requests or at least some level of metadata in some sort of ClickHouse database from all the centers, like wherever they're getting some request. Then they are doing some processing over here for like some time. And then based on that processing, they are generating a feature file, which then gets propagated to all their network. Now, the reason they are doing this is, for example, let's say it's daytime in India, right? And Cloudflare is getting a bunch of traffic here and it's analyzing this traffic and it detects like some sort of bot or malicious activity that's going on. What it can do is that it can use that learnings and it can propagate that instantly to centers in US or Europe or in Middle East and anywhere, basically. So it can take the learnings that it's getting from one country or one area, for example, and it can create a feature file for its bot management, and it can propagate that learning once every 5 minutes and so to everywhere in their network, right? Because they don't want bot attacks which are unrecognized to spread very fast. As they say, it allows them to react to new types of bots and new bot attacks. So it's critical that it's rolled out frequently and as rapidly as bad actors change their tactics quickly, right? So this could be some set of IP addresses which they want to blacklist. This could be some sort of user agents or patterns or the way like their machine learning model is figuring out. Could be anything, right? A change in their underlying ClickHouse query behavior that generates this file caused this to have a large number of duplicate feature rows. This changed the size of the previously fixed size of feature configuration, causing this bot module to trigger an error. Alright, so what they're saying effectively is that this feature file, in general, what happened was this file became a lot bigger than it was supposed to be, and I'm assuming that this file, when it started to load inside every of these infrastructure pieces, started to crash every single one of them, right? The problem here fundamentally is there was some bad query or something which was written here. There was no check on this feature file, just an assumption, and that assumption led to pass this feature file to every single network nodes over here, and it just kept on crashing the whole network. Unrelated to this incident, we were and are currently migrating our customer traffic from a new version of our proxy service internally known as FL2, which is frontline, right? That is what they mentioned above, FL, frontline. So they are doing it from FL2 to, that is where they are migrating it to frontline. Both versions were affected by the issue, although impact observed was different. Customers deployed on the new frontline 2 proxy engine observed 500 errors. Customers on our old proxy engine, known as frontline, did not see errors, but the bot scores were not generated correctly, resulting in all traffic receiving a bot score of 0. Okay, so my initial assumption that Cloudflare is doing probably 20 to 30 million requests every second is slightly wrong. It could be a little bit higher because they are saying that there are some people who are still, some customers were already on frontline engine, which did not see 500 errors, but they had basically a lot of false positive. Customers who were not using our bot score in their rules did not see any impact. Throwing us off and making us believe that this might be an attack was another apparent symptom we observed. Cloudflare's status page went down. I also saw that. So you see that generally, one interesting observation, I don't know if you guys have paid attention to this or not, but generally what happens is that when you are as big of a company like Cloudflare or even AWS and Google Cloud, you can't make cyclic dependencies, right? For example, system status page cannot be part of the Cloudflare's infrastructure itself. Some of you might find it weird that why this is hosted on CloudFront or which is on AWS, but this makes total sense because of incidences like these. For example, you cannot put Cloudflare's own status page inside their own infrastructure because that beats the whole point of having a status page. Status page should be available when your services are not available for customers to see. But in this case, the status page also went down probably because of the DDoS or sort of like customer induced DDoS, right? So Cloudflare says that internally we were discussing that this might be like an actual attack or an actual DDoS attack, but this was not a DDoS. This was just AWS just seeing a very sudden spike in traffic, right? But this was interesting, right? So Cloudflare uses AWS for its status page, which is why status page mostly stayed up. It went down for a few minutes, but it was mostly up and they were able to push updates regularly. Had this been routed via Cloudflare's infrastructure, even at like a basic level, right? So even at this point, like when the origin is also not reached, you would have seen that your status page would also be 500. All right, so what exactly went down? So you see that they mentioned that a change in the underlying query behavior resulted in feature file containing large number of duplicate rows. The database system in question uses ClickHouse software. It's helpful to know how ClickHouse distributed queries work. A ClickHouse cluster consists of many shards. To query from all the shards, we have so-called distributed tables in a database called default. The distributed engine queries the underlying tables in a database R0. The underlying tables are where the data is stored on each shard of a ClickHouse cluster. Queries to distributed tables run through a shared system account. As a part of efforts to improve our distributed queries, there is work being done to make them run under the initial user accounts instead. Before today, ClickHouse users will only see the tables in their default database systems when querying table metadata. This was the type of query that performed that was performed by the bot management feature file generation logic to construct each input feature for the file mentioned at the beginning of the section. So they have omitted a lot of details, I would say. Obviously, this is not clear, like what exactly is this table or what exactly is it storing and so on. What they're effectively saying is that they rolled out a change to their ClickHouse database cluster over here, which explicitly exposed another database in the system called R0, right? Default was already there, but R0 is also now available. Now what happened here is, if you look at this query, it's saying that select name type from system columns where HTTP request feature. So they're making a SQL query, but they're not specifying the database name itself over here, right? So what exactly started happening was, if you see over here, you will see that now because two of these databases are somewhat sharing same data, they have started to return duplicate records, right? From the R0 schema, effectively more than doubling the rows in the response, ultimately affecting the number of rows. I don't know how it doubles, how it does more than double, because if it's basically duplicating the work, it should be exactly double, but maybe I'm missing some details here. So it's definitely returning duplicates, that understandable, which doubles the file size, but they're saying that it effectively more than doubles the rows. All right, so we have a little bit of explanation now that what happened with this feature file. How does it became so large? Basically, it doubled, at least that is what we know, because of a query problem that happened, and not exactly a query problem. Basically, they made a database, a new database available to queries, available to users, which in turn resulted in more data being returned by the system, and then henceforth creating this feature file larger than what it was supposed to be. Now the actual problem happened was because this feature file had no constraints as such on what should be the size of this, when at the time of creating, it just automatically got propagated or got pulled away by these systems, right? So you see in this memory pre-allocation section, each module running on our proxy service has a number of limits in place to avoid unbounded memory consumption and to pre-allocate memory as a performance optimization. In this specific instance, the bot management system has a limit on the number of machine learning features that can be used at runtime. Currently, that limit is set to 200, well above our current use of 60 features. Again, the limit exists because of performance reasons. We pre-allocate memory for the features. When the bad file with more than 200 features was propagated to our servers, this limit was hit, resulting in the system panicking. So I'm assuming, because they are saying that the limit was 200 and the features were 60, you have effectively more than tripled, not doubled the size, right? If I'm not wrong. At least this could be also just outright wrong, but I'm just assuming if the duplicated work is just 2 times or slightly more than 2 times, then I think even 200 should have been fine as a number. The FL2 Rust code that makes the check and was the source of the unhandled error is shown below. Okay, so you are seeing Cloudflare's internal code base. Good to know that they also use Git internally. I was assuming they would use something else, but they do use Git. So this is a Rust code block where they are fetching the features. They have the checksum and then they unwrap the feature values, which panicked because of the memory pre-allocation. So there is not enough memory allocated for loading such a large file that the whole process crashed. This internally obviously resulted in the white screen of death from Cloudflare, which was 500 errors. And you could see that they're explaining that their other systems that rely on their core proxy were also impacted because Cloudflare internally uses a lot of their own systems internally. We have seen this with R2 going down this year, and I think Workers KV also going down some time back, if I'm not wrong. So you see, effectively the bug here was this feature file getting a little bit of bloated, and I would say the oversight here is that this file, if this was so important to have like a limited size and there were pre-allocations and things happening, it should have, obviously I am just plain outright wrong, but this is what I feel should have been the thing. It should have a check on feature size or file size basically before this gets propagated away, because obviously the check is there on runtime, but that runtime check effectively assumes that this file will never grow, right? So this was actually a core dependency, because even in future maybe like somebody grows up this list of 60 features to 200 features or maybe like a little bit more, you don't know where is that information or knowledge that this file must not be propagated beyond a certain feature size, right? If these are like 2 separate components somewhere, because this file is getting generated over here in the ClickHouse database and this file is getting used over here in their whole network. I'm assuming that these code bases are slightly different. They could be part of a single monorepo or something, but they would have some level of gap between their deployment part and where they're actually getting executed. So this check would have prevented this, because it would have at least not updated the feature files 5 minutes. That would have probably made like it's possible for 1% attackers who are doing attack uniquely in that specific time range to do it, but it's still better than just bringing down half of the internet. That is what I think they also mention indirectly here, hardening ingestion of Cloudflare generated configuration files in the same way we do for user generated input. So that is what exactly they were missing, right? So they assume that this feature file is extremely trusted piece of system code that you can just put across anywhere you want. But this check or validation, I would say, effectively makes it possible to block this deployment here itself instead of it getting propagated through the whole network. Enabling more global kill switches for features. Again, one interesting observation is that because they mentioned throughout the thing that only their bot management WAF was failing, which is actually, if you think about this is not a critical part of the system. Yes, it is critical in terms of stopping DDoS attacks and something, but not as critical as just shutting down the whole internet. So if given the option, Cloudflare could have removed this part completely, right? That is where they say that enabling more global kill switches for features should be there. For example, if they want to remove bot management completely, they should be able to do that. They can't do a lot of these things. For example, they can't remove TLS termination. That will effectively mean the same thing, but you can do bot management. You can probably also do WAF and rate limiting till a certain extent. You can remove turnstile, the captcha and all of that. So you can remove the blockers. You can't remove things that accelerate. So you can't remove TLS, and you can't remove like origin or serving response. But this stack is somewhat of a security measure, right? This bot management WAF check, if you go back in their diagram, you will see this part over here, WAF rate limiting bots. This is all optional stuff. It's good to have. It will create a lot of problems if you keep it down for a very long time, but not so much if you just, if you see that half the internet is down, maybe we can plug the switch on these features and bring it back up first. Eliminating the ability for code dumps or other error reports to overwhelm system resources, and reviewing failure modes for error conditions all across core proxy modules. So anyway, this was stressful day, I'm sure, for Cloudflare in general, but I mean, like it goes, like you learn from your mistakes. They just don't have to be your mistakes alone. So I am sure that a lot of cloud providers, including Vercel, AWS, Google Cloud, all of these platforms will learn from what has happened today with Cloudflare, and they will work on fixing if they also have this pull sort of architecture for their global edge network infrastructure, right? Because you might feel like, global networks are resilient and they will not crash. Even if it crashes, it will be located to a specific data center or region. But things like these show that if there is anything which is like not isolated, completely isolated, if the updates are not isolated, they are not checked before they propagate, it can cause some problem at some stack. And these things are extremely hard to know ahead of time until and unless they have happened or not happened. You can obviously do some sort of monkey testing and chaos testing and so on to figure out these problems. But yeah, I mean, let's just hope that Cloudflare had a good learning from this incident yesterday. So that's all for this one. If you liked it, make sure you leave a like and subscribe to the channel. I will see you in the next video very soon.